So in the previous video, we saw how to declare new data types in Haskell. In this video, we are going to have a look at some important data types that we can use while writing our programs. And a data type that we may want to implement is an optional data type that, given some types already implemented, gives us the possibility to make a value of that type optional. And in order to do so, we will have one constructor of this data type that will take nothing as input, since this constructor is meant for the case in which the optional data type does not have any value, and a constructor that takes an instance of that type and wraps it into the some value constructor, meaning that we successfully got a value of this type. Well, of course, this type may turn really useful, but turns out that Haskell does already have such a data type, which is called maybe. And maybe, like our data type, is a parameterized data type, as we can see also from the kind of maybe, and does have two constructors, one called nothing, for the case of which we have no value, and one called just a, where a is the type of whatever value we are holding, and this value is wrapped, as in our case, into the just constructor. And one case in which maybe may turn useful is while parsing strings into other values, and Haskell does already have a function that does that, and it is called read. And in order to use read, well, we have, of course, to provide a string, but we have to specify the return type, since it can be many things if not specified. And of course, we can specify how to evaluate a specific expression by using the colon and then the type of the expression we expect, and this is valid. We parse successfully this string to be an integer value. Notice how without this, the read function would have throw an exception, and the read function throws an exception also if the given string does not respect any valid string to be parsed into the expected type, and we can see that. And if we want to handle cases in which given strings are not parsable to the type we expect, we can use a function defined into the text.read module, and you have now available a function called read maybe, which, given a string, returns a maybe a, so returns something that is readable wrapped inside our maybe data type. And by using this read maybe, and of course specifying the return type also under the form of a maybe value, we can get back our value if the string is, of course, valid to be parsed. But in the case of the string not being valid, in this case for an integer, we just get a nothing and no error is thrown. And this is a wonderful use case for the maybe data type. It allows our programs to run even when some values are not present. And of course, since maybes are defined using data constructor, we can use also pattern matching while working with maybes. And one way to use pattern matching can be to define a function that in this case I called unwrap maybe, which, given a maybe value and a default value, returns a value of the type we are working with. And in the case the maybe instance has been constructed using the nothing constructor, then we use the default value to evaluate this function call. If instead the maybe instance has been constructed with the just constructor, so we do have some value. We ignore the default value and just return the value we got from the just constructor. And we can load this file so that we do have this function available in our GACI shell, and we can use this function like so. So given a nothing, which is a valid instance for any maybe value, and a default value, which in this case will be 0, will return, in this case, of course, 0, since we do have no value in the maybe instance. And actually the type signature is not really useful here, since GAC is able to understand the type of any from the default value, so this will evaluate as well. And if we here provide a value of maybe constructed with the just, then we return that value without the just. And of course, just here is just a function. In fact, provided with a value returns an instance of the maybe, which is the value wrapped into the just constructor. And you can, of course, even ask for the type if you are not sure. And we see that just 2 is something of maybe a, where a is a number. Another useful data type that we do have in Haskell is the either data type, and we get that either as a kind from any type to any type and gives us back any type. So as we can of course also see from the definition of either, we see that it takes two types as arguments, and it does have two constructors called left and right. And the left constructor holds a value of the first type we provide to the either data type, whereas the right constructor does hold a value of type equal to the second we provided to this either data type. And of course, we do have valid instances of either only when we provide two types, and also with types we do have partial function application. In fact, we can ask for the kind of either, and we see that it is the one so before. And we can also ask for the type of either int, and this is something that given some type return at the end a valid type. So a valid type that can have instances is something like either int or string. And we see that we get back just the asterisk, so we know that either int or string is something that can have values. And one useful way to use this either int or string would be with lists. In fact, lists can only hold one type of values, and say we wanted to hold both strings and number inside our list, that would be possible in plain Haskell, and we would have to wrap those values inside the either constructors. And I'm wrapping the numbers in the left constructor and the strings into the right constructor. So this is actually a list that is holding types of instances, either numbers or string. And we can of course evaluate this expression, and this is totally valid. And if we ask for the type of this expression, we see that we have here a list of either a, where a are numbers, and list of chars, which as we know are meant to be strings, as we read here. So I'll leave you in the file also this value, just to remember you one of the possible way to use either. And let me also copy the definition of the either data type as we did for maybes. And before closing this video, let me introduce you another important data type, which are tuples. And tuples are defined like so. Well, actually the actual definition is not explaining how to build a tuple, but you can just put some values inside the parentheses and separate via a comma, and those two values do not have to be of the same types as we also see here, and this is a valid value. In any case, the tuples, actually the pair tuple, is defined like so, where we do have one constructor, and this constructor takes an instance of an A type, which we specified in the particular type definition, and the same for a B type. In fact, as we see here, the kind of a pair tuple is something that, given two generic types, returns an entirely new generic type. In fact, the type of the previous expression is something like a tuple of a number, as we see here, and a string. As we know, this list of char is a string, and we can actually also have tuples with more than two values, and I don't really know if we have a limit for the number of values that a tuple can have. The important thing of a tuple is that it is fixed. Once we do have a tuple, those are the values inside that particular tuple, and a part of holding multiple values not constrained from a particular type, we do have also some important function, the curry, which, given a function from a tuple to a C, returns a function that, given an A, a B, and a C, that given an A and a B returns a C, and what it does is just technically unwrapping the values of the tuple into some arguments of a function, and this function is the opposite of the uncurry function, which, given a function like this one, so something that given an A and a B returns a C, returns a new function like this one, which, given a tuple of A and B, returns a C. So say we have a function like f of x and y equal x plus y. We can now provide this f to the uncurry function, and we will get back another function. So I'm storing this result inside a variable that I call f prime, and by the way, single quotes are valid chars in order to define names of variables. And now I can use f prime like so, which is more similar to the syntax of other programming languages, and this is a valid function call, since what we are doing is just providing a tuple to the function f1, and this call is then equivalent to do this call with the simple f function. And yeah, that is a way you may want to use tuples. And we can also use pattern matching with tuples, and in this case I'm using pattern matching in order to unwrap the values used to construct the particular tuple instance. And I've defined two functions, one called getFirst, which returns the first value of the tuple, and one called getSecond, which returns the second value of the tuple. In any case, those functions are already defined inside Haskell and are called fst for first, and one called snd for second, and we see that the type signature is the same. So in this video we had a look at the maybe data type, the either data type, and the tuples. We saw some use cases for each of these data types, and I hope this video was useful to you. If that was the case, consider to subscribe to the channel. If you want to support the creation of this content, in the description below you'll find the link to delegate your ADA to Harmonic pool and earn interest on top of supporting this series. In any case, I want to thank you for your time. Remember to stay decentralized, and I will see you in another video. Bye bye.